Hey pre-calc, welcome back. Our objective today is going to be to find partial fraction decompositions. Since I'm kind of doing some algebra backwards, which becomes really handy for calc when we are doing certain types of integrals. So I'm going to force pause on the screen. You know what to do from here. I'm forced another pause on the screen. Can you go ahead and copy the two examples I have on the screen? Hit continue when you are ready to continue. All right, we are back. So what I want to do is first go forwards, like add these like we're used to doing, right? So when I add two fractions, am I allowed to just add numerators and denominators straight across, or do we need common denominator? We need common denominators, right? So I'm going to move this a little bit. So here, look at your two denominators. You've got x minus 3 and x plus 2. Neither of them share common factors. So what I'm going to do is I'm going to make a common denominator of x minus 3 times x plus 2, right? So I'm going to say, okay, this first fraction is missing the denominator of x plus 2, and what I do to the denominator, I also need to do to the numerator, right? The second fraction is missing the factor of x minus 3, and again, what I do to the denominator, I need to do to the numerator, okay? So now my denominators are good to go. So now I can write this. Now I'm just going to add now I can add my numerators straight across, right? And don't worry about simplifying for now, okay? So I'm going to have quantity x plus 2 times 2. So I'm going to write that as 2 times quantity x plus 2 plus, and then 4 times the quantity x minus 3, right? Okay. Can you try this one on your own? So very similar, I just have a and b instead of numeric values in the numerator. Hit continue when you are ready to check. And again, don't simplify anything. Just leave your denominator factored and your numerator just in basic form there before you would distribute. All right, hit continue when you're ready to check. All right, this is what we should have gotten. If it's not what you got, go ahead and pause and make corrections. But notice again that our two denominators don't share any factors, so I need both factors in the denominator. This makes my LCD, my least common denominator, x plus 4 times the quantity x plus 5. If I go to fraction a, it was missing the factor of x plus 5. That's why I've got a times x plus 5. And if I go to fraction b, it was missing from the LCD the factor of x plus 4. So that's why I've got b times x plus 4 for that part of the numerator. First pause on the screen, go ahead and write the fraction I have. Okay, so our goal today is going to be to go opposite of what we just did. So instead of giving you like two fractions and you combine them, I'm going to give you the combined version and I want you to separate it, because separated with just like a linear denominator in calculus is a lot easier to work with than what I have on the screen right here. Okay, so what we want to do first is say, okay, if I'm going to separate these, let's say, into two fractions, then first I want to factor the denominator. So the denominator factored would be what? The x plus 4 times x plus 5, or the other way around. Order isn't going to matter here. It'll work itself out. So what I'm going to do is, since there are two factors, two linear factors for this denominator, I'm going to make the first fraction have a denominator of, say, x plus 4, and the second fraction have a denominator of x plus 5. Again, had I chosen it to go the other way, that would be totally fine. Okay? Now, if I were to add these two fractions together, then I would need a least common denominator, right? And that would be x plus 4 times x plus 5, which is exactly what I started with here, right? Okay, now my goal is, I know what the denominators are going to be, right? My goal is to find what are the numerators going to be. So I'm going to call them A and B for now, and do a little bit of algebra to figure those out, okay? All right, so got your A and your B ready. Now, if I were to combine these two fractions, the denominator I know works, but the numerator, again, they need this LCD, so write this, fraction A, I would end up needing to multiply fraction A by x plus 5 to get back to combine, right? So now I'm going to have x plus 5 there. Fraction B is missing the x plus 4. Okay, so if I were to combine these, my new numerator, remember unsimplified, is going to be a times x plus 5 plus b times x plus 4. That would be my new numerator, agreed, once I combine all of them, okay? My denominators are already equal. My next issue that I need to solve is to make my new numerators equal to my old numerator, okay? So if I were to combine them, my new numerator would look like this, and again, I need to set that equal to my old numerator, right? Because I want them to be the same. Okay, so again, still trying to find what? Still trying to find a and b. So here's what we're going to do. We're going to pick some clever x values to make this easy to solve. So take a look at this orange piece here. What value of x would make the orange piece 0? -5, right? So write this. We're going to do x equals -5. And anywhere I see an x in this equation, I'm going to replace with -5, okay? So I've got a times -5 plus 0, so that's 0. I have a times 0, that goes away. Already looking good, okay? Now I've got b times -5 plus 4 equals, again, x is -5, so -5 plus 6. So simplifying this, I have b times -1, which is -1b, equals -5 plus 6, which is 1. So dividing both sides by -1, I have that b is -1. Okay, I've got b. What's left to find? What's left to find is a. So now come back to this equation, look at your green factor. What would make that green factor disappear? X equals -4, right? So come back now to, again, this equation. Anywhere you see an x, replace it with -4. So I've got a, and then I've got -4 plus 5, plus b times 0, right? So that's going to go away, equals -4 plus 6. Okay, so -4 plus 5 is 1, so a times 1 is a, and then -4 plus 6 is 2. And now I have my a and my b. So let's write our final answer. Come back to what we originally wrote in purple. Let me clean this up a little bit. All right, so I'm coming back to this fraction, and I found a. So I'm going to replace a with -2. I'm sorry, with +2. And then I'm going to replace b with -1. So what I'm going to do is I'm just going to make this a -1 right here. Okay, and when I add these two fractions together, they should equal what I started with here. Okay, why don't we double check? So just this one time here, let's check our answer. So if I were to combine these fractions, my common denominator is x plus 4 times x plus 5. This fraction with the 2 is missing the x plus 5. Minus 1, this fraction is missing the x plus 4. Okay, so common denominator stays, and once I distribute on that, we know that's x squared plus 9x plus 20. Distributing the numerator, I've got 2x here and then a minus x here, so that's 1x. Then distributing the 2, I have 10 here, minus 4, and 10 minus 4 is 6, and that is exactly what we started with, so we are good to go. All right, and force pause on the screen, can you go ahead and copy the fraction that I have, and then also think about what two factors would get you to your denominator here. Go ahead and hit continue when you're ready to continue. All right, so we want to split this up into two fractions because my two factors multiplied to give me this trinomial will be x plus 2 and x plus 4, right? When I multiply those together, I get back to this fraction. If you did x plus 4 and x plus 2, that's totally fine. Again, it's going to work its way out either way. All right, now my question is going to be, well, what are my two new numerators? So let's call it a and b. All right, so let's set up our equation. What I would need if I were to add these up, I would need the common denominator. Fraction a is missing what factor? It's missing the x plus 4, right? again, if I were to add those fractions together, I would need to multiply fraction b, numerator and denominator, by what? By the missing factor, which is x plus 2. So what I have so far right here, that would be my new numerator if I were to combine those two fractions, right? And I need that to equal what? I need it to equal my old numerator, x plus 8, okay? All right, now I can let x be whatever I want, but let's pick some sly x's and make our work easy. So take a look at this equation. What x value would make the green factor be 0? -4. So I'm plugging -4 for all my x's, and this is simply to make my work nice and easy because it's going to make a go away completely so I can solve for b. So when I plug in -4, this goes away. This becomes b times the quantity -4 plus 2. -4 plus 2 is -2, so I've got -2b equals, and then -4 plus 8 is +4. So dividing both sides by -2, I get -2, right? Okie doke, let's try the same thing for the orange factor. What x value would make this piece all go away? -2. All right, so plugging in -2 for all my x's into this equation, I've got a times the quantity -2 plus 4. When -2 plus 4 is +2, so I've got +2a. When I plug -2 in, it makes this orange piece 0, so this second term just goes away completely. And then I've got equals -2 plus 8 is +6. Dividing both sides by 2, I get that a is 3. All right, so let's come back to our original setup here. So I'm going to just make sure that you come back to what you called a and b. So a is +3, b is -4, so I'm going to make this a minus 4. Okay? All right, really the most common mistake I see with these is students when they go, oh, for fraction a, that was the denominator of x plus 2, and for fraction b, it was the denominator x plus 4, and they're not thinking about what is the fraction missing from the common denominator. They just say, oh, it has this denominator. Yeah, be careful there. Okay, it's what's missing from the LCD. That's what I would end up multiplying numerator and denominator by. So just make sure you don't go so fast that you lose what you're doing. I apologize, b was -2, so make that correction there for me. Okay, how can we check? Maybe with the graphing calculator. We could graph the original, and we could graph our answer and see if we get the same graph. Let's take a look at Desmos. Okay, so here, let's do this. Here's the original graphed in red, and then I've got our answer in the second line in blue, and you can see those are perfect matches, so those look good. First, pause on the screen, go ahead and copy the fraction, and see if you can set up the two fractions, the two denominators for me. Okay, hit continue when you are ready to continue. All right, so maybe you set it up like this, where you have a over x plus 1 and b over x plus 1, because x plus 1 times x plus 1 is this, right? And that's a good start. However, if you add up these fractions, what's the common denominator? It's just x plus 1, right? They're the same thing. So when you have repeated factors, we have to deal with this a bit differently, because right now this isn't going to work for us. I don't have the correct denominator for what I'm looking for, because again, when I add these two, neither of them is missing anything from the LCD. They're already good to go, okay? I really need, though, my LCD to be x plus 1 quantity squared, right? That's how I would factor this. So when you've got repeated factors like x plus 1 squared or x minus 3 to the 4th, you've got to work your way up to those factors. Here's what I mean. Let this first one be x plus 1, okay? What is the multiplicity on on what we're trying to get to? It's a 2, so you're going to work your way up. The first one's going to have a power of 1, which I don't need to write, right? Then after 1 we get 2, okay? If this were a 3, I would have another fraction with a denominator of x plus 1 to the third power. Okay, so you've got to work your way up to that repeated factor. Okay. Other than that, we're pretty good to go. Okay. So again, our LCD is x plus 1 quantity squared. Fraction A is missing a factor of x plus 1. Right? However, fraction B is not missing anything. Okay, so my new numerator, if I were to combine these, add them together, would be what I have right here. All right, and I'm going to set that equal to my old numerator. All right, pick a clever x for me. What would be a good one? -1, right? When I pick x to be -1 and plug it into this entire equation, this first term goes away. I still have the b, and the right side becomes 3 times -1 plus 5, which is +2. All right, so there's my b value. Now, I don't see another factor that I can just like nicely make a or b go away, right? So pick any other x value. I like to just pick 0, okay? So let's let x be 0 and come back here. When x is 0, I get a times 1, so that's just a, plus b, but I know what b is, right? B is 2. So plus 2 equals, and then I've got, again, I'm plugging 0 in for x, so I've got 0 plus 5, so that's 5. So when I subtract 2 from both sides, I get that a is 3, right? So now I can come back here and let a be 3, and b is going to be 2. And again, we could check this on a graphing calculator, right? Plug in graph the original, graph my answer, see if it works. I could also double check by adding them by hand and seeing if we get back to what we started with. All right, so this here is my final answer, okay? I do want you to make a note for yourself because this was different. How come? Because we had this repeated factor of x plus 1. It was x plus 1 times itself, x plus 1, okay? So make this note for yourself for me. Right, beware of repeated factors, okay? When you've got repeated factors, you have to work your way up to that multiplicity. So, force pause on screen. Go ahead and write that. Hit continue when you're ready to continue. All right, and force a pause on the screen. Go ahead and copy the fractions that I have. The numerators are missing on purpose. And then hit continue once you've got them all copied. All right, so for example 4, our last example, we're just going to do setup only, okay? So like for this one, the denominator factors as x plus 2, x plus 4. So neither of those repeats. So I would go x plus 2, x plus 4, a, and b, and that's it. I'm just doing setup only for these, okay? And first pause on the screen. See if you can get the other two on your own. Beware of repeated factors. Hit continue when you're ready to check. All right, I've got the answers on the screen, so pause if you need to change anything. Notice that your denominator here factors into x minus 5 times x minus 5, so x minus 5 quantity squared. So again, it's that repeated factor. I've got to work my way up to that multiplicity of 2. If I look here, you've got it factored already, so that's nice. But notice that you have only 2 unique factors, and this factor of x repeats itself, right? So I've got to work my way up to that 2. So factor x to the 1 and then x to the 2. Then deal with the second factor, okay? It's, we've got a power of 3 there, so I've got to work my way to that power. So I've got x minus 4 to the 1, x minus 4 to the 2, x minus 4 to the 3, okay? And again, this was set up only, but really look at your factors. If you've got any repeats, you've got to be very mindful of how am I going to create that LCD so that when I do add all these up together, I get back to the desired denominator. All right? Okay, y'all, that's what I have for today. I will see you next time.